program. These are all pretty common things, and these are the things that they put in this first criterion. The authority and freedom. This is pretty important, where you have the authority to make decisions, to affect change, to audit, to do these kind of things, and the freedom to do that outside of cost and schedule, independent of cost and schedule. Another criterion is the program itself. These are all kind of upper level type things, not too different than anything else. SSCs are systems, subsystems, components, and structures. Structure, systems, and components. Organizations, control conditions. The 10 CFR 50 requires that you establish a program that identifies the systems that you're going to watch out for, and of course these are safety-related systems, and the organizations are responsible for the quality assurance program, for doing the activities within quality assurance. You have to maintain controlled conditions. If you're going to be acting in a nuclear reactor, you have to ensure that the conditions are controlled to the point that they have to be to do the quality assurance activities that you require. Special processes, tools, equipment, and skills. This is where you have to define that. We have inspection and testing to make sure that you check your own work and to make sure that work is checked for you. Training, this is kind of an interesting thing, and the fact that training, which many of us consider to be extremely important, is actually a subpart of this quality assurance program, and we make sure that managers actually do review the program. When we talk about 10 CFR 50, we're talking about the design and operation of nuclear reactors. So design control is an extremely important part of that, and that's the third criterion that we look at when we're looking at the NRC-based quality assurance requirements. Design bases are, what are we looking at? Well, how big can an earthquake be? You know, we had the problem in Japan recently, and they said that that tsunami on top of the other disasters they had was beyond the design bases. They never designed for that big of a natural disaster, and we had the same thing. We were told that a particular reactor in South Florida is going to have an earthquake. I don't know if they have earthquakes in South Florida or not, but we have to worry about a certain seismic event down there, and so that's the design bases. Then we have to worry about the regulatory requirements that the NRC puts upon us and says, you have to make sure that you watch out for this, and watch out for this, and watch out for that. And all that has to go into drawings and specifications and procedures. And when we audit, we spend an incredible amount of time looking at these kind of things. Did you actually put these things into your drawings, your specifications, and your procedures? Have the quality requirements been specified to make sure that you actually do comply with this program? Have you identified and controlled the design interfaces? We're talking a lot about designing reactors, so we need to make sure that A is talking to B and B is talking to C and so forth. Wasn't too long ago in the space program where one group in the space program was using metric measurements and the other group was using SAE measurements, and amazingly enough, they didn't mesh very well. So that's the part that we spend a lot of time talking about design interfaces. We verify it, and then we also worry about change control. Make sure everybody, no matter what quality assurance branch you're in or what industry you're in, worries about change control. And criteria number 4 is procurement document. We buy a lot of stuff from a lot of different companies, and when the NRC looks at us, they make sure that we translate our requirements. We specify our requirements very carefully in the procurement documents that we have. If we're going to go buy something, we have to make sure that the requirements that are placed upon us are imposed upon our suppliers as well. And we audit the auditors, we audit the supplier's quality program. These aren't too big a deal here. Instructions, procedures, and drawings, acceptance criteria. We're required to make sure that all of the things that we do are documented very clearly. And the NRC is really, really nuts about documentation. If you read the auditing handbook that ASQ puts out, it talks about interviewing auditees and talking to them and getting their impression of things. Everything we do is documented. We can't accept anything that's not on paper. If it's not written down, it doesn't count. And that's the way that all of our audits are. And so our procedures, our instructions, and our drawings are just incredibly important. And each one of these, if we're going to have to accept something, the acceptance criteria have to be in there. Document control is pretty simple. Document review and approval. Document distribution, we have to make sure that the right document is on the floor wherever they're doing the work. And we have to make sure that we take back documents that have expired. we go out and we audit people and we say, oh, you're using a revision that's 10 revisions out of date. That's not acceptable. So hopefully our procedures prevent that from happening and change control. Let's see, these are not too big a deal here. Control of purchase material, equipment, and services, that's pretty much the same thing that we already talked about. When we express our requirements to our suppliers and make sure that what they're going to provide to us meets the requirements that we have and meets the requirements that we supply. You know, we're not an end user. We supply things to different utilities, so we have to make sure that our requirements are passed down, that those requirements are applied to the equipment, material, and components that we get from those people, and that they provide things that meet those requirements. This is an unusual point. I don't know if it's present anywhere else, but documentary evidence available at the plant. You have to make sure that when we buy something from a supplier, if you're supplying to us, something else supplying to us, we buy it from you, and we take it and we deliver it to a facility, we have to make sure that all the evidence that that was a good part goes with it. Because the NRC comes in a year from now, 5 years from now, 10 years from now, and they say, oh, where did you get this fork? Is this fork really meet the requirements? And they want to see the documented evidence that it really does meet the requirements. So this stuff stays around. All items have to be identified and traceable. That's something we do. Special processes, that was quick. Doesn't matter. It was welding, heat treating, and the light that I need to get back to. Good? No. We have a lot of people that do welding. So we have people going out and watching the welding, watching the heat treating, watch the non-destructive testing, and all the procedures that are used for that. All the people have to be certified, all the people have to be trained, all the people have to use procedures that have been reviewed and approved by the appropriate people and so forth. So this is a big deal for us because we do a lot of welding. We go out to reactor sites and put fix reactors and things and do all kinds of welding and heat treating and non-destructive testing. Test control, nothing big there. Control of measurement and test equipment, this is probably the same. Everybody has that. If you have test equipment, it's the same thing. Handling, storage, and shipping, inspection, testing, operating status, non-conforming materials, parts, and components. These are standard things. I really wanted to try to show you some things that were different, that the NRC does differently than anyone else, and these are all pretty standard, from my experience. I mean, I don't have a great deal of experience in different industries, but these are all fairly common. Corrective action program. This is one that we spend a lot of time on, that the Nuclear Regulatory Commission spends a lot of time on, and we get dinged constantly about because we have to be so careful about this. Conditions adverse to quality are identified and corrected. We have thousands of those. You know, they're just simple things. It could be anything from the fork is dirty to a reactor piece doesn't work quite right. But where we really get into the areas of significant conditions adverse to quality. And each supplier gets to define that as they see fit. Those we have to make sure we understand the cause. Why did this happen? We do a lot of root cause investigations. We do a lot of apparent cause analyses to determine why these things happen. And then hopefully, in our company and all the people I get to work with in the Nuclear Regulatory Commission regulated area, spend a lot of time trying to preclude recurrence. You know, to err is human, to keep it up is stupid. So we really try to find the reasons behind these things, and we make a big point of it. And when all of our people come in and audit us, they always look at this. Have we done this correctly? Records, pretty much the same. I'm sure everybody has the same type of thing. You have to have records. They have to be identifiable and retrievable. It's silly to have records if you can't get them back. And the NRC specifies these things are lifetime records and these things are not lifetime. That's probably common. Audits, comprehensive, planned, and periodic. We have to audit each of our departments every year, and we do this every single year. We audit constantly. We do internal audits constantly. We do supplier audits constantly. We're always looking at how we might better ensure that people are doing the things that they're supposed to do. And yet we still have thousands of corrective actions. I don't understand that. One of the strange things, and this really seemed very odd to me when I got to working in an NRC regulated activity, was this whole idea of reg guides. Now, I don't know if you're familiar with the NRC, but they put out these regulatory guides. Section 1 is nuclear power plants. There's 9 sections or 10 sections, something like that. And Section 1 has probably 100 or 150 reg guides. And the NRC comes out and they don't really tell you what to do. My experience in quality is somebody will come out and they say, you do this, these are the instructions, this is what you have to do. They don't do that. They come out and they say, and this is the whole thing from the paragraph, but it doesn't really matter too much until you get to this part where it says, are acceptable to the NRC staff and provide an adequate basis for complying with the requirements of this appendix. There's this document, NQA1, and a lot of people do it with NQA1. DOE uses it, NRC uses it, and so forth. They don't say you have to use it, they just say it's acceptable to the NRC staff and provides an adequate basis for complying with the requirements. So if the NRC comes into our company, or to any other company that's regulated by them, if you don't use NQA1, that's fine with them, but you just have to be able to prove that you can do it. And these reg guides get really confusing in some cases because this is the reg guide that applies to the general nuclear plant. The plant where you're generating electricity and things. If you have computer-controlled equipment there, that has another reg guide. The coating that you use for paint, that has another reg guide. And there's another reg